Alright, here we go. Exercise 4BC, quiet down. Shh, quiet down. What I taught you yesterday. Quiet down. Don't talk much with me. Exercise 4B and C were truncus and square root functions. I taught you how to read left, right, up, and down. What I want to do today is to work on your algebra. So now that you can read the equation, the next part is to read the algebra so that you can solve for x-intercept, y-intercept. That's what the worksheet is all about. Okay, once you can find x-intercept, y-intercepts, you can then sketch. So here we go. Let's go with the first one. Let's do what we read from yesterday. What's a -4? Tell me again. Can I please have Brian? Up, down. So if it's -4, Hamish, what does that mean? Down 4. So I know this graph goes down by 4. So my asymptote changes from y equals 0 to now y equals -4. Next one. What do I also have? I have another asymptote. Yasmin. Where's the other asymptote? At x. So normally it moves left and right. What about this case here? Doesn't move left or right. And how do you know let x equal 0? And in this case, x just equals to 0. Which means it doesn't move left or right. And the asymptote is still at x equals to 0. Whereas the y value, we said down 4. So I already got my asymptotes here. Down by 4, y equals -4. Okay, so remember, horizontal is y, vertical is your x. Now, what you need is your x-intercept and y-intercepts. How do I find my y-intercept? Can I please have Najma? What do you do to find your y-intercept? Let x equal to 0. So that's what I'm going to do. Copy this down. Here we go. Y-intercept. Let x equal to 0. This is my equation. I'm going to let x equal to 0. Now, if I let x equal to 0, I've got 1 divided by 0 squared -4. What's the issue here, Matt? What's the problem? It's undefined. We can't do 1 divided by 0. We can do 0 divided by 1, but we can't do 1 divided by 0. This is undefined. So if it's undefined, what does that mean? What does that mean, Trent? What was the question? Sorry. So if I'm trying to find the y-intercept and I got 1 divided by 0 is undefined, what does that imply?
That there is no y-intercept.
That there is no y-intercept. And it makes sense because if you look at the graph here, we have an asymptote on the y-axis. So it means it never touches the y-axis. So it never touches it. Of course you're not going to get an intercept. Okay, so it makes sense why you don't have an intercept at x equals 0. So there is no y-intercept. Okay? Then let's now find x-intercept then. Let's see if it crosses the x-intercept. How do you find out if it crosses at the x-intercept? Let y equal to 0. So here we go. We're going to say let y equal to 0. I'm going to let y equal to 0. Now this is where I want you to practice the algebra. I want you to copy the technique down. You got 1 over x squared -4. What do you do again, Ryan? Plus 4. Get it to one term. Right now I've got 2 terms. I've got this fraction, that's one term, -4, that's the second term. Get rid of any other terms, leave the fraction by itself. That's how you do it first. Yeah, just like the other exercise 4a. Get rid of the 4 first, so adding 4 on both sides. So I'm doing this, add 4, add 4. Yes, fantastic. And this is what I've taught. Every time you get a fraction, get rid of it. See, this means 1 divide x squared. If you don't like the fraction, opposite of division, which is times by x squared, because opposite of division is times. So I'm timesing both sides by x squared. We normally do the denominator, makes it easier. Yeah? So now, you're left with 4 times x squared, which is 4x squared. You've gotten rid of the x squared, so it's 1. Now, no, before you do that, remember you're trying to find x. So you got to get rid of this 4 again, and get rid of the square. That's what you want. You just want the x. So I got the 4 as a problem. How do I get rid of the 4?
Square root.
Not square root. Sydney? Divide by 4 on both sides, because this actually means right now 4 times x squared. To get rid of the 4, opposite of times is divide. So I'm going to divide both sides by 4. So 4 divided by 4 cancels out. Now I've got x squared equals to 1/4. Now you do what here? How do I get rid of the square? What do you do? Now you square root. Because that's BODMAS, yeah? BODMAS says that you deal with the indices first before you do the multiplication, so you go backwards. Get rid of the multiplication, get rid of the indices. Now when I get rid of them, I'm going to square root both sides.
So I can't square root x squared.
Square rooting x squared will cancel out the squares.
Yeah.
I get x equals to the square root of a quarter. Now when you're square rooting a quarter, what can you square root? How do I write my answers here? What's the square root of a quarter? Rachel, what's the square root of a quarter? It isn't half. Because what you can do when you're square rooting, you can square root the numerator and then the denominator. Square root of 1, 1. Square root of 4, it's 2. But the only one thing you got to be careful of when you square root, don't forget the plus and minus. Because every time you square root, I don't know, it could have been half squared or it could have been negative half squared. And it still equals a quarter. Okay, so you found out x equals to a half and x equals negative half. So on your axes, you got negative half and you got half. There's my axis intercept, right? And now we sketch the graph. Now what does a truncus graph look like again? Yeah. What does a truncus graph look like again? Like a tree trunk. Yeah, so if I draw it, it makes sense why it crosses those 2 points. So I use the axes and I draw them. I'm like, all right, never touches the y, crosses through there, never touches y equals negative 4. Yeah, I kind of missed the point, but you got the idea, or you got the point, right? This is anything squared in the denominator is a truncus. Why are you listening?
How like the Y-intercept, it's like can't add it because it's 0 but it's undefined.
Yes.
Does that mean you never have a Y-intercept?
In this particular graph, yeah. That's why it approaches it. It never touches it.
Like you add like in the X section that part X squared, you like it's like be like minus 4 or something, right? Well, like you still can't square 0. That's still make it undefined.
If you have an x minus 4 in here,
X squared minus 4.
no, if it was, oh, that's a different graph. That won't be a truncus function. That'll be something else. But it's a good question. In that case, you can still have 0 squared, but the minus 4 on the side would not make it an asymptote. But it's not a truncus function. It has to be all squared. Yes, unless you move it left and right. So by changing the denominator. So if you had x minus 4 all squared. So if I gave you 1 over x minus 4 all squared, that shifts the graph to the right by 4. Yeah? All right, next one. Here we go, let's revise this one. What kind of function do I have here? Can I please have Trent? Talking too much.
Yes.
What kind of graph do I have here?
You have a root.
A root graph.
Back. Yes.
Yes, okay. Now a root graph, what does a square root graph look like again? Look at your notes again. Fantastic. It's like a sine-on parabola, but only half of it. Okay, so we know square root graphs look like this. It's going to curve on the side. Let's read what they've given us. What's the minus 4? Tell me now, Lauren. Down 4, fantastic. This means down 4. Now does this graph move left or does it move right at all, Finn? Does it move left or right? In this case here, you can see whatever you're square rooting in there, whatever you change the x, that will move left or right. In our case, it's just x equals 0. So it stays at the center, down by 4. Yeah. Very good question. So, with a square root function, this is more about for year 12 concept. When we say a function, in our case, when you put a square root here, it's a positive. I know normally when you do the algebra, when you square it, it's a plus and a minus. In a function, this will always be positive. Yeah. It's only unlike the other one. The other one, when you square it both sides, that's when it becomes positive or negative. Okay? So in this case here, I know it goes down by 4. And then I now need to know where are the x-intercepts and y-intercepts. Now it's pretty obvious that the y-intercept is 0, 4, but in case you didn't know, you can still solve for it. Again, let x equal to 0. Square root of 0, which is 0, minus 4, it makes sense. Y-intercept is -4. Now what I'm interested in is how to find the X-intercept. Now X-intercept is when y equals 0. Copy this down. Y equals 0, this is what I get. So how do I solve this now? So it's all inverse operations. What you've been doing since year 7 to 9, same thing. What am I going to do first? How am I going to solve this? I want to solve for this. You've got two terms. The first goal is 2 plus 4. Get rid of that term. You've got a -4, add 4 on both sides. You get 4. Now your goal is to get x. I've got a square root. How do I get rid of the square root and? Square. Because the opposite of square rooting is squaring. So if I square both sides, I will get rid of the square root and squares, and x will equal to squaring, not square rooting. Squaring. Yeah, not square rooting. Different sign. See, this is a square root. Square, square root, square. Yeah? 4 squared means 4 times 4. That's why I know it's 16. That's my x-intercept because I let y equal to 0. So now you put it all in. 16, 0. And we know that the shape before I told you the square root looks like this. So here we go. There you go. That's your graph. Okay, that's your graph. It curves out. Okay, so you have the square root. Opposite of square rooting is squaring both sides. I got rid of the square root by squaring. X equals to the square of 4, 16. Alright. That's what I want to do. So on the worksheets that you guys have, that's what I want you to do. Find x-intercept, find y-intercept, find x-intercept, find y-intercept, and then sketch. Okay? Lawrence. Okay. Let's do another example. Let's add in some negatives now.
You know, for the graph, I did a one different point, right?
I'm going to do this one. I'll help you individually later.
No,
yeah?
I mean for this one.
I'm doing this one now.
No, this is a different. Yeah. For square graph, right? This is for the ability.
Yep.
Yeah, but
That's what I'm going to do, Ian, but you keep stopping me. Yeah? All right, here we go. Let's do this one. Quiet down. Stop talking. Finn, I warned you, yeah? All right, here we go. We've got y equals -2 over x minus 1 all squared. Same thing. Let's read what we have. We've got an x minus 1, but remember that's all squared. So what does the x minus 1 tell me?
That's right.
To the right by 1. How do you know again? Let it equal to 0. That was the technique I showed you in quadratics, right? X minus 1 equals 0. X equals 1, so that means to the right by 1. If I know it's to the right by 1, what's the -2 do? Will? Yep, the 2 makes it wider or smaller, but I'm asking the negative. Upside down. Okay, so we now know the shape of a truncus normally looks like this, but it is not positive, it is now negative, so it's upside down. Good. So it looks like that. Okay? Now let's put in what we have. I said right by 1, so I'm going to draw my asymptote right by 1. That's what I want you to write down. Talking again, I'm going to move one of you three, yeah? It's every session. Every single session, I'm tired of that. So I'm already giving you a warning. Next lesson, if I catch you guys talking, I'm just going to move you. No complaints. Fair call? All right, so we're moving to the right by 1. So you've got your vertical asymptote. X equals 1. This is my vertical asymptote. Where's my horizontal asymptote in this case? Y equals 0, because it doesn't move up or down. Okay? It doesn't go. Y equals 0. So here we go. I'm going to draw my asymptote. Y equals 0, because it doesn't have a plus term. If it had a plus term, you would have shifted up or down, but you haven't, so it stays at y equals 0. Now you got your shape, as in your new axes, you got your new asymptotes. Now you got a sketch. Now in order to sketch, you need an x-intercept and a y-intercept. So how do you again find the y-intercept? Let x equal to 0. So let's follow this through. Finding the y-intercept. Letting x equal 0, this is what I got. Negative 2 over 0 minus 1. Now 0 minus 1 is negative 1. Negative 1 squared is 1. Negative 2 divided by 1 is negative 2. So that tells me I've got a y-intercept at negative 2. Now this is where it gets tricky. It's always the x-intercepts that's hard. Now I want you to practice on that one. So here we go. I'm going to let y to 0. What do you do here? Fantastic. Whatever the denominator is, that's divided by x minus 1 squared times both sides by the denominator. So in this case here, I'll say times x minus 1 squared times x minus 1 squared. And what you can see, the issue is 0 times x minus 1 squared. What does that become? 0. And the problem is you get 0 equals negative 2. What does that mean?
Not x-intercept.
It's undefined. So if it's undefined, it is
Not x-intercept.
no x-intercept. So there is no x-intercept, but there is a y-intercept. And it makes sense. Because you drew an asymptote on y equals 0, of course you won't have an x-intercept. How is there an x-intercept if you said there's an asymptote there? Okay, so it doesn't cross or touch the x-axis. So if I were to draw my graph now, y equals negative 2. So let's say negative 2 is here. I know it's a upside down truncus, so here we go. This is what my graph looks like. Okay, so it's just an upside down graph, y-intercept, but it doesn't touch the x-axis. It's negative because, yeah. Okay?
How about if I draw it? How about if I draw it?
Sorry?
How about if I draw it so shit, like so shit? Like, I get an idea about my drawing so shit.
Oh, they'll be really bad. You'll lose marks. Alright, here we go. Here's my last question, and I'll get you guys to do on your worksheets, and we'll touch base on the square roots. Remember how you can have different sides in the square roots? I want you to look at your notes and tell me what the negatives do again. So let's have a look at this. Plus 2. Plus 2, Ben. What's a plus 2 tell me? Good. Up 2. What about this one? 1 minus x. Be careful with this one. Ben. 1 minus x. What does that tell me? To the right. And how do you know again? Like I said, use my technique. Let it equal to 0. Now if you let it equal to 0, you can see minus x equals negative 1. 2 negatives. Make it positive. So if it's positive 1, what does that tell me?
So you can't have a negative x equals 1, right? If it's a negative x equals 1, you move the negatives to 1.
Yeah. Yeah, we don't want the negatives. So we're timesing both sides by a negative 1. If it's x equals 1, that means it's moving to the right 1. So now I know right by 1, up by 2. Okay, so it's always let that equal 0. Well, why do you think this one looks different to every other one? I'll put a negative there. What does that do again? Which one is it? Good. It's reflected opposite side, not upside down. It's gone to the other side. So remember, there are 4 ways of sketching your square root graph. Remember, you can have the positive one, which is root of x. How do you get, and this is the root of negative x. How do you get it upside down? How do I get this one? Negative on the outside. Very good. So this will be negative. Whoops. Oh, what happened there? Negative of root of x. See how the negative's on the outside? Negative's on the outside of the square root. Negative's inside of the square root. Turn this way. Now how do I get it going this way now? Good. Negative on the outside, negative on the inside. So if you notice those 2 negatives, in my case, I've got a negative on the inside with the x. That one will turn this way. Because if I have, let's say, root of negative x, yeah? Now if you put a 1 in, if you sub in 1, you can't square root that, true? But if I put a negative 1, if I sub in negative 1, 2 negatives become a positive, true? See, so if I did square root of negative 1, and those 2 negatives become positive, that's why all the negative numbers on this side would work. That's why the graph goes this way. Whereas if it was positive, it was going that way. Okay? So now we know the shape. We know that it has to go this way, okay, because it's got the negative in the square root. Now we're going to solve for the y-intercepts. How do you solve for the y-intercepts? Let x equal 0. Sub 0 in. 1 minus 0. Root of 1 plus 2, which is 3. Y-intercepts are 3. To find the x-intercepts, here we go. Let's find the x-intercepts. Let y equal to 0. Here we go. What are you going to do from here? Minus 2. Always get rid of the extra term. So that's a plus 2. Minus 2 on both sides. Now, if I minus 2 on both sides, I need to get rid of the square root. What's the opposite of square rooting? Squaring. So I'm going to square both sides. Here we go. We square. We square. Square and the square root will cancel out. I'm left with 1 minus x. Negative 2 squared, we know, is 4. So here we go. We got 4. And over here, I said that's a positive 1 minus 1 on both sides. 4 minus 1 gives me 3. But remember, as Brian just said before, we don't leave our answers with negative x. So the answer has to be negative 3. So now I've got my x-intercept. I've got my y-intercept. I know the shape of the graph. You said to the right by 1, up by 2. So here we go. To the right by 1. I'm going to move the graph. Here we go. To the right by 1, up by 2. And you know the shape of the graph was meant to be this way. Okay? Now, that doesn't make sense. We do something wrong here. Minus 2. Oh, minus 3. How's it minus 3? Have I done something wrong? Did I plus 1? I don't see what I've done wrong. Anything? Anyone seen?
Oh, you wrote wrong intercept, sorry?
No, square roots don't have asymptotes. That's weird.
So check answer.
So the right by 1, up by 2, that should be correct. There shouldn't be any x-intercepts.
Logic sounds pretty good on program.
Yeah. Oh, okay. I think I see why. All right, this is a good one. The problem is it gets a bit more complicated when I explain it. A square root function, Ryan asked before, when you square root, it has a plus and a minus answer. True? Normally, when you square root 9 will give you negative 3 or positive 3. The reason why, when you sketch a graph, it's called a function. You don't know what a function is yet, so I won't explain too much into that detail. But this graph, square root function, is actually, Finn, thank you. When you do a square root function, it actually has 2 sides to it. It's actually got a top and a bottom to it. It looks like a side-on parabola. That's why x squared looks like that. And then the inverse would be like that. Okay? Now, there is a top and a bottom to it, but because you're squaring it, it doesn't matter if it's negative or positive, it negates that idea. And that solution that you potentially have is only in the negative section. Okay? And right up until this step, before we even need to solve, we're meant to know that this is not possible. Because square root of a number, doesn't matter what that number is, every time you square root, it's not possible to get a negative number to begin with. So if you square root 4, square root 5, square root 6, they're all positive numbers. How is it possible that square root of 1 minus x, whatever that answer is, you can never get negative 2? At this point, we're meant to say it's undefined at that point. Sure. Okay, so right here, none of these would work because it's impossible to square root a number. Doesn't matter what that number is. It just can't be negative. You can't have a square root of any number to give you a negative number. That's why that's undefined at this point. It's just impossible. Okay, It's kind of like 1 divided by 0 is impossible. The square root of a number can never be negative.
So there is no X-Intercept.
No X-Intercept. So in our case, that's our answer there. It only works if you add a negative at the front. Okay? It only works if you add a negative. All right. That's it. Anyways, thank you. I didn't even pick up on that one there. Square root, just write that down somewhere in your own notes. Square root of any number can never equal to a negative. So at this point, it should have been undefined. Okay, so this should have been undefined. Okay? Because you can't square root a number to get a negative. No matter what you do, you can't square root anything to get a negative answer. It's not possible. It's like saying 1 divided by 0 is just not possible. Okay? Okay, cool. Alright, excellent. Now this sheet that's going around, for every one of them, I'm asking you to do truncus, square roots. I want you to do exactly what I've been doing, X-Intercepts, Y-Intercept. Towards the back, that's where you sketch. But at the start, you're just doing algebra. This one I want you to do for today's lesson, and tonight, I'm going through this solution because we got a double session. We've got a double session tomorrow. So the first session, I'm going through the answers with you. And we'll do circles 4D tomorrow. Okay? So that's what I want. Doing this in this session, you should have the ability now to do X-Intercept, Y-Intercepts, and both graphs. Okay, do tomorrow. I'm checking you guys as well. Horizontal, vertical. Y equals is the horizontal, and X equals.
Horizontal.
Yep.